All right, welcome everybody. Mr. Hauser here, trying out our first visual lesson, our virtual lesson. Going to work right out of the comp book, just like normal. Thank you to those of you who have already subscribed and ready to receive instruction. Let me know in the comments. Sounds so weird to say that. Let me know in the comments about audio and visual clarity so that I can make sure you can see and hear appropriately. Okay, we'll start off with something basic, a review. Also, for those of you concerned about who turned in work right before the break, I'm going to sit down right now after our lesson and put those grades in so those won't be missing anymore. By the way, if you didn't read the email in full detail, make sure that you do. And if you didn't receive that email, let me know and I will email that back out to you. It details many things, important things being tests are now able to be redone for an average credit of the 2 test scores. That's a big one for a lot of you. So if you need to bring a grade up, that would probably be the most effective way to do so. Make sure to get in communication with me if you want to redo a test, and we can make arrangements. Okay, so right before we left off, we were moving into polynomial operations in Algebra 1. And an important skill that I don't want to go away is factoring. So let's make sure, look at this, table of contents, just like old times. Today is the 6th, 2020, review, factoring. And I'll have an attached assignment with this video. I think I can link a attachment. If not, I'll put it up as an assignment on Student View. We'll see what I can do. Okay, so factoring. Remember, there are 2 kinds of factoring. Factoring trinomials specifically. That's what we're doing. All right. Factoring. Trinomials. Both when a is equal to 1 and when a is greater than 1. Let's see, right about there. Okay, for instance, x squared plus 7x plus 10. Now, what is factoring? Factoring is kind of like undoing the multiplication that we did to get here. So 2 binomials had to multiply to make this. Right? If we think about our box method, our polynomial operations, prior to this, we learned to multiply. So something on each of those boxes, an x and an x, multiply to make an x squared. The question being, what 2 numbers have to add to make 7 and multiply to make 10? Those 2 numbers are 2 and 5. So 5x, 5 times x is 5x, 5 times 2 is 10, x times 2 is 2x. This is called the sum and product method. It's always what 2 numbers add to make the middle term and multiply to make the c. Apologize in advance, my handwriting is going to be sloppy just like you. You probably haven't done much writing in the last 2 or 3 weeks. Also, again, advantages of video. If I'm going too fast, what can you do? Pause it. Also, I'll leave opportunities to pause so that you can work it out before I proceed and answer some of these problems, okay? So another one, another example. X squared plus 12x plus 35. Think about your sum and product. I'll wait. Pause for video. Okay. What 2 numbers add to make 12, but also multiply to make 35? well, let's see, numbers that add to make 12. 6 and 6, 9 and 3. None of those are making 35. Of course, the answer is 7 times 5 and 7 plus 5. So the answer you can write as a binomial pair, x plus 7, x plus 5. Okay, that's the simpler method, the factoring when a is equal to 1, sum and product method. When your coefficient of a is greater than 1, that's when the problems become significantly more difficult. Okay, we just have to use a different method, a different strategy. Let me pick one out here. Yeah, that'll work. Okay. 8x squared minus 16x minus 10. Okay, remember if our coefficient is greater than 1, we have to do something different. We have to multiply a and c. First thing I should notice though, or check, are there any greatest common factors? Question mark. Greatest common factors in all of these terms. An 8, a 16, and a 10. Sure, there's a 2. A 2 can be taken out. Take out a 2 first. Make your numbers smaller. 4x squared minus 8x minus 5. Okay, so we've taken out the greatest common factor. That's going to make our process easier. If that wasn't available, we'd still have to move on to this next step. So step 1, greatest common factor. Is there one or not? Step 2, remember, multiply a times c. A value being the first term, c value being the last term. A, b, and c. Multiplying 4 times negative 5 gets me negative 20. That's now the number I'm looking for the product of, and sum to make negative 8. Hopefully this is ringing a bell. Okay, we need our box method. We're going to undo the box. Remember, reverse Sudoku is what I refer to it as. So we have 4x squared. We have negative 5. And these two terms have to add to make 8, negative 8, and multiply to make negative 20. What are those two numbers? Think about it. I see negative 10 and positive 2. Those two numbers would multiply to make the negative 20 and add to make the negative 8. So negative 10x and 2x. And now we do our reverse Sudoku. X times x must have made the x squared. X times negative 10 must have made the 10. Nope, can't be that. 5. Negative 5. Nope, can't be that. 2. Nope, can't be that. Pause. Okay, brain fart there. 2x squared. 2x there. 2x there. 1 there. Negative 5 there. Yeah, whew. Sorry about that. 2x plus 1. 2x minus 5. 2x minus 5, 2x plus 1. That was pretty sloppy. Let's make sure we got that down. Do one more, and then I'll finish up our 9-minute video. Okay, we will make this one a little bit more complicated, but now we're warmed up, right? Okay, notes don't need to be so organized anymore. 6x squared plus 11x minus 72. Can I find a GCF? Question mark. 6 and 72 have a common factor, but 11 does not. 11 is prime. I'm going to have to multiply 6 and 72. Gosh, Mr. Hauser, I remember these. These are terrible. I have to figure out what multiplies to make this huge value, whatever 6 and 72 are, and adds to make 11. You're kidding me. Nope. Remember, factor trees. 3 and 2. Let's see, for 72, let's go 8 and 9, 3 and 3, and 4 and 2, and 2 and 3. So there's more factors of 72. 3, 2, 2, 2, 2, 3, 3. Okay, those are all of the prime factors of 6 and 72. Sorry, I'm messing with the camera now. How can we recombine those to make a sum of 11? Yikes. Okay, how about the 4 2's, which would make 16? There we go. And the 3 3's. If you put all the 3's together, 3 times 3 times 3, 27. If you put all the 4 2's together, 2 to the 4th is 16. If you subtract those two, you get 11. Perfect. Perfect. Okay, so we have our A value in here, our C value in here, and our two values that combine to make our, that's a positive 27 and a negative 16. Whoops, crash. All right, so reverse Sudoku. I'm betting that that's an X, of course, an X and an X. I'm thinking 2 and 3. 2 times 3 is 6, 3 times 9, 9 times negative 8. That works out, yep. 2 times negative 8, 16x. Perfect, so our solution, or not our solution, our two factors that made this polynomial are 2x plus 9 and 3x minus 8. Okay, so practice those. I'll give you an assignment, 10 questions. We're only supposed to give you one assignment a week. I'll probably post more than that though, just in case you want to keep engaged. But definitely practice this. If you have any comments, jokes, make fun of me, whatever, leave them in the description or leave them in the comments below. Also, remember again, any advice on audio or visual quality, please let me know. Look forward to getting more comfortable with this and doing this more often with you all, and hopefully I get to hear and see you guys soon. All right, signing off. Bye.